All right, today we will be moving on to section 1.3. Section 1.3 is a review of trigonometric functions. So something that I want to make clear is that the book we use actually goes really in depth, okay? It basically reviews all of trig. For the purposes of our review stuff right now, I do not want to review the whole thing simply because I think that would be throwing too much at y'all right now, okay? So what I'm going to do is I'm going to review the basic trig stuff, okay, and then whatever else we need I will review throughout the class as I go, okay? So like I said, this right here is just a basic review of trig stuff, okay? So the first thing I want to review, something else that might be a handy tool is for you to have a unit circle. Okay, it would be very helpful to have one of these. We are just going to use a lot of trig stuff throughout this whole class, and so having this is going to help you. Okay, so just have one of these, and it's going to help you a ton. Okay, so to start, there are two ways to measure an angle. There are two ways, and by that I mean if you have two rays like this, if I have a ray there and a ray right there, there are two ways to measure the space between them. Okay, there are two ways to. The first two, which is the most commonly used one in the real world, is going to be degrees. That's the one you've probably heard the most about. And then the second one is radians. Now, even though degrees are most commonly used in the real world, whenever you study like math or engineering or anything like that, we are mostly going to use the radians. So these are the most used ones in calculus and really in any other science. We use this one more. Okay, so the first thing I want to know then is how do I convert between them? Let's talk about some conversions between degrees and the radians. So first things first, to convert degrees to radians. So if you have degrees, how I change it to radians is I multiply by pi over 180. Remember in the recording for section 1.1, I said that if you ever see pi, just leave that as pi, okay? I meant this right here. So like pi, we are just going to leave that as pi, okay? And then to go backwards to convert radians to degrees if you ever need to. Sometimes in some of our real world word problems, we will need to do this. How I could convert radians to degrees, we're going to multiply by 180 over pi. So basically just flip it. So let's practice doing that really quick. Example, convert 225 degrees to radians. Okay, so as I wrote down, in order to convert degrees to radians, I just multiply that, 225, by pi over 180. And then I just have to like reduce this as much as I can, okay? So first things first, 225 and 180 both have a factor of, let's do 5, because I can see that. Both of these have a factor of 5, so divide 225 by 5, and you get 45, so that brings you to 45 pi on top. 180 divided by 5, 5 goes into 18 3 times with a remainder of 3. 5 goes into 36 times. I can reduce that still. 45 and 36 both have a factor of a 9. 45 divided by 9 is 5, so that gives you 5 pi. 36 over 9 is 4. So 225 degrees is 5 pi over 4 radians. Again, I did that just by multiplying by pi over 180 and then reducing that as much as I can. Let's do the same thing. Let's convert 210 degrees to radians. So the same thing, we're just going to do 210 times pi over 180. I can clearly see both of these have a factor of 10. So that would bring us to 21 pi over 18. And then both of those have a factor of 3. 21 divided by 3 is 7. So 7 pi over 18 divided by 3 is 6. So that's 7 pi over 6 radians. So now let's practice going from radians to degrees. Because like I said, sometimes in some of our real world stuff, we are going to have to do this. Let's convert 5 pi over 3 radians to degrees. So as I said, to do that, we multiply by 180 over pi. So 5 pi over 3 times 180 over pi. And let's see how I can reduce this, okay? First things first, I see I have a pi there and a pi there. So cancel out that pi. And then I can do 180 divided by 3. 180 divided by 3 is 60. So all I have left is 5 times 60, which is 300. So 300 degrees. Again, like I said, we just multiply it by 180 over pi and then reduce it as much as we can. Let's do one more example of that just to make sure we have it down. Let's convert 11 pi over 6 radians to degrees. So like we said, how I do that is we multiply it by 180 over pi. So as I can see, pi's cancel out. And then I can do 180 divided by 6, which is 30. So all I have left is 11 times 30, which is 330 degrees. So that's how I move from each form right there. All right, so the main thing I wanted to review for trig is something we are going to use a lot, and those are the 6 basic trigonometric, which is a fun word to say but a hard word to spell, trigonometric functions. Okay. So there are 2 ways I can look at these things. The first way is if I have a right triangle. So I want to draw a right triangle. Right angle right here. Let's say theta is this guy right there. So this side over here is going to be the opposite side. This side is going to be the adjacent side because I'm going to touch it, right? And then this longer side is the hypotenuse. Or you can look at it like on a unit circle, like what I showed you guys a while ago. Unit circle on the XY plane. Imagine that's a circle. I cannot draw, as you guys are going to learn. And let's say I had an angle right here that stops at a point XY. So both of these are both ways I can look at trig stuff, because both of them form right triangles XY. Okay, the 6 basic trig functions are sine and sine of theta. If we're going by the triangle over here, sine is going to be the length of the opposite divided by the length of the hypotenuse. Or if we go by the circle right here, It's just the value of the y. It's the value of the y right there. Our next basic one is cosine. Another big point I didn't say, but the length of this line has to be a 1. That's the whole point, is it's just 1. But that doesn't really matter a whole lot for what I'm trying to show you here. Okay, the next one is cosine of theta. Cosine using the triangle is adjacent over hypotenuse, and using the circle is x. The next one is tangent. Tangent is opposite over adjacent right here, or if I'm using this guy, it's y over x. We also have cosecant theta, which is just sine but flipped. So it's going to be hypotenuse over opposite, or 1 over y. So it's just going to be flipping it, okay? Then we have secant, which is just going to be cosine flipped. So hypotenuse over adjacent, or 1 over x. And then I thought I left myself enough space right there, but I did not. So I'm just going to scoot it over wherever it'll fit. Cotangent theta. That's going to be tangent flipped. So adjacent over opposite, or x over y. This is the main thing I wanted us to review. I wanted to make sure we remembered this thing here, okay? So first things first, we are going to practice finding the trig values of some angles using the unit circle, okay? So we're going to practice that first. So if you have one, have it out or handy or pulled up or however you have it. Example, we're going to evaluate each of the following. The first thing I want us to evaluate is sine of 2 pi over 3. So like I said, it's going to be very helpful if you have the unit circle out. So I'm going to get mine out. Excuse me. So I'm going to look for 2 pi over 3. I'm going to look for the angle that says 2 pi over 3. And here it is right here. 2 pi over 3 is right there. Excuse me. And so as I wrote down, sine, whenever I use that guy here, sine is the value of the y on my point, right? So 2 pi over 3 is right here. The y on my point is the square root of 3 over 2. So the sine of 2 pi over 3 is square root of 3 over 2. Square root of 3 over 2. That's it. So like I said, I'm going to find 2 pi over 3. 2 pi over 3 is right there. And sine is equal to the value of the y on my point. So I look at y. And I write it down. That's it. That's all that I've got to do. So let's try, on that same note, let's do cosine of 3 pi over 4. Cosine of 3 pi over 4. So again, I'm going to get my circle out. And I'm going to look for 3 pi over 4. Keep looking, keep looking. There it is. 3 pi over 4 is right there. So I want the cosine of that. We said cosine was the value of the x. So it's negative 1 over the square root of 2. Negative 1 over the square root of 2. Now, depending on the math class you had, whether it was trig, pre-cal, and depending on what your teacher wanted you to do, you may have learned this as being negative square root of 2 over 2. That is also a right thing, okay? The calculus book we have does not care which way you have it, okay? And personally, I do not care, okay? However, mathematically speaking, the most correct way is this way right here. And let me explain why, okay? So in terms of math, we do not like it whenever there is a square root in the denominator. We don't really like this, okay? And so how I get rid of a square root in the denominator is I'm going to multiply it by the square root of 2, because the square root of 2 times the square root of 2 is just 2. So doing so gets rid of the square root. However, if I do it on the bottom, I've got to do it on the top too. So I've got to multiply the top also by the square root of 2. Okay, so one more time, I did this because I don't like having a square root right here, and so I'm going to multiply that by the square root of 2, because the square root of 2 times the square root of 2 is just 2, and so that's going to get rid of the square root sign. Okay, so doing that, negative 1 times the square root of 2 is negative square root of 2. Square root of 2 times the square root of 2 is just 2. Again, the textbook does not care. Personally, I do not care, but mathematically speaking, this is the correct way. Negative square root of 2 over 2. Okay, so moving on to the next example. Let's look at this one. This one's good. Let's do sine of negative pi over 6. This one is a good one. Okay, so notice on the unit circle right here, everything is positive, right? Positive pi over 6, positive pi over 4, positive pi over 3, blah, 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 right? Negative means instead of going counterclockwise like I normally do, I'm going to start here and go clockwise. Hang on, my screen froze. Let me show you that again. I'm going to go clockwise, okay? I'm going to go clockwise by pi over 6, okay? So pi over 6, normally I go counterclockwise and it's my first one, right? So since it's negative, I'm going to go clockwise to my first one. Something I just saw right here, the circle I have shows this as 11 pi over 4. That should say 11 pi over 6. So just be careful right there. That should say 11 pi over 6. I don't know what happened there. I got this from the book, so that's a little strange. But 11 pi over 6 is what that should say, okay? Okay, so to recap, normally I go pi over 6 right here, which takes me to the first dot. However, since it's negative, go backwards to the first dot. So I'm using this point right here then, okay? I want the sine of that, and as we have said, sine is the y, so I'm going to look at the y, and it's negative 1/2. So sine of negative pi over 6 is negative 1/2. Using that same idea, let's do cosine of negative 5 pi over 6. So again, just like I said right here, the minus sign means I'm going to go clockwise instead, okay? So normally 5 pi over 6 is over here. So I go all the way to the second to last dot on the top half, okay? So it's the second to last dot. So if I'm going backwards, that's going to take me right here. Okay, so I'm going to go to this point right here. I'm asking for cosine, and so that is the value for x. So it's negative square root of 3 over 2. So negative square root of 3 over 2. So that's how I deal with the minus signs inside of there. One more example. This one is also a great one. Tangent of 15 pi over 4. Tangent of 15 pi over 4. Okay, so like I said, normally I'm going to look for the angles inside of here, right? So I'm going to look for them inside of here. However, if I look, 15 pi over 4 is not there, right? 15 pi over 4 is not there. But if you notice, since this is a circle, a full round, if I look at it, is 2 pi. So what I can do is I can keep doing full rounds until I get to 15 pi over 4, okay? Each circular round is 2 pi. So let's subtract 2 pi from here and see how much is left after doing a full circle, okay? So let's do 15 pi 15 pi over 4 minus 2 pi, so 2 pi over 1. I need a common denominator, which would be 4. So times 4 times 4, that's 15 pi over 4 minus 8 pi over 4. 15 minus 8 is 7, so 7 pi over 4. So let's see if 7 pi over 4 is there. And if I look at the angles that I have, there it is. It's right there. So what this means is to get to 15 pi over 4, I have to do a full circle and then keep going again until I get to 7 pi over 4 right here. So I'm using this dot. Okay. Tangent is y over the x, so I'm going to do negative 1 over the square root of 2 divided by 1 over the square root of 2. Again, negative 1 over the square root of 2 divided by positive 1 over the square root of 2. To divide those, remember we keep, change, flip, so that's going to be negative 1 over the square root of 2. That's our keep. Change this to times, that's our change, and then flip that one, square root of 2 over 1. Square root of 2's cancel out, so I'm left with negative 1 divided by 1, which is negative 1. Negative 1. So now that we've done that, let's do it using triangles like we showed we can do right here. Okay, so let's do some with that. Before we do that, I just want to state a theorem that I know you have heard. I know that you have. I just want to write it down to make sure. And just in case you have not heard this, you can hear it now. And that is the Pythagorean Theorem for triangles. And what this says is if you have a right triangle where the legs are side lengths A and B and the hypotenuse is side C, then the side length A squared plus the side length B squared is equal to the side length of C squared. So I just wanted to write it down. I know we know this. I just want to make sure. Okay. So using that, let's look at this example. Consider the following triangle. I want you to find the missing side and, sorry, that should have said and, all 6 trig functions at angle A. So I'm going to draw a triangle with a missing side, and we're going to find what the missing side is, and then list all 6 of the trig values. So this triangle is going to look like this. The right angle is right here. This is going to be angle A. This is going to be side A, which is 84. This is going to be side B, which I'm going to let be 13. And this is going to be side C, which I don't know. So first thing I've got to do is find out what the length of side C is. Okay. So I know from this rule right here, I can do A squared plus B squared, and that is equal to C squared. So again, because I know A squared plus B squared is equal to C squared, I know A is 84, so 84 squared plus, I know B is 13, so 13 squared is equal to whatever C is squared. So let's do this out. 84 squared is 7,056 plus 13 squared, which is 169, is equal to whatever C is squared. Add these guys up and you get 7,225 is equal to C squared. So now in order to find what C is, I just take the square root of that. And the square root of 7,225 is 85. So side length C is equal to 85. So now that I know what all 3 sides are, I can find the trig values for angle A. So first one is going to be sine of angle A. Remember we said on our list a while ago that sine is equal to sine is equal to opposite over hypotenuse. So that's going to be 84 over 85. We said cosine is equal to adjacent over hypotenuse. The adjacent is 13. The hypotenuse is 15. So 13 over, the hypotenuse is 85. So sorry, I tried to talk way too fast. The adjacent is 13. The hypotenuse is 85. So 13 over 85. The tangent we said was opposite over adjacent. Opposite is 84. Adjacent is 13. So 84 over 13. Remember we said cosecant is just sine flipped. So since sine was 84 over 85, cosecant would be 85 over 84. Remember we said secant was just cosine flipped. So since it was 13 over 85, it would be 85 over 13. And then lastly, cotangent was tangent flipped. So since it was 84 over 13, it's going to be 13 over 84. So that is how I find the missing side, and that's how I find all 6 of the trig values there. I have one more example that I want to do, and that's going to be all of the trig review I want to do. For now, like I said, as we go through more of the calculus stuff, I'm going to review some more things. I just think if I did all of it, it would be too much. And so that's why we are only just going to do just a few things here and there. We're going to do the same thing. I'm not going to rewrite all of it. We're going to do the same thing with a different triangle. So this time I'm going to have a triangle. This is going to be angle A. Side length A is going to be 4. Side length C is going to be 7. And we're actually not going to know side length B. So now I want to solve for side length B. So this is going to work the same way, except instead of solving for C, I'm going to solve it for B. Okay, so I still want to use the same a squared plus b squared equals c squared thing. Same thing. Except now I know a and c, and I want to use those to solve for b. Okay, so a I know is 4, so that's going to be 4 squared. I don't know b, and so that's going to stay b squared. And then I know c is equal to 7, so 7 squared. And then now let's work that out. 4 squared is 16, so 16 plus b squared equals 7 squared is 49. To solve that for b, we need to subtract 16. So b squared is equal to 49 minus 16, which is 33, if I'm right. Yes. And then to solve that, I find the square root of it. Now, 33 is not a perfect square, and so it's just going to stay b equals the square root of 33. So the missing side length is the square root of 33. Remember I said in this class, whenever you have a square root of some stuff, just leave it as a square root. Okay, so just like that is fine. So now let's find the trig values of A. So sine of A, remember, is opposite over hypotenuse. So 4 over 7. Cosecant is going to just be that flipped, so 7 over 4. Cosine of A is going to be adjacent over hypotenuse, so square root of 33 over 7, and secant of that is just going to be cosine flipped. So 7 over the square root of 33, but remember, technically, we do not like having a square root in the denominator, and so we're going to multiply that by the square root of 33 over the square root of 33 to get rid of it. So on top, we'd have 7 square roots of 33 over square root of 33 times the square root of 33 is just 33. But again, I'm completely fine if you leave it in this format here. I don't care. This is just the more correct way. Tangent of A is going to be opposite over adjacent. So that's going to be 4 over square root of 33. But again, we don't really like having a square root down there. So multiply by square root of 33 on top and bottom. So 4 square roots of 33 over 33. And then cotangent of that is going to be flipped. Instead of trying to flip this and trying to rework it, I'm just going to flip the one that I had out front and just do square root of 33 over 4. All right, so that is going to be all we are going to review for now. But like I said, as we go on through calculus, I am going to review a few more things. But for now, that is good. Remember, if anything does not make sense, please let me know ASAP so that we can work it out, okay? Because I don't want y'all to go through this class unsure about stuff, okay? All right, so that is the end of our trig review. Next up in section 1.4, we are going to learn a little bit about inverse stuff, okay? All right, so I will see y'all then in section 1.4.